to Educate Foundation YouTube channel, and we will be continuing with our basic hydrology lectures. That is, today we are looking at the saturated vapor pressure curve of water vapor in air. If you haven't subscribed, make sure you subscribe, make sure you like, comment, and share this video to anyone out there. So let's zoom into it. So we'll be looking at SVP's curve, that is saturated vapor pressure. Saturated vapor pressure. Now, there are two things that are related to the saturated vapor pressure curve. So we have our vapor pressure or the saturated vapor pressure on the y-axis and the temperature on the x-axis. So assuming at a given instance, let's say here, we have two coordinates, the temperature and the vapor pressure. Now, when I trace the temperature at this point to touch the SVP curve, the corresponding y coordinate is what? My saturated vapor pressure. In that case, the temperature that I use to get my saturated vapor pressure is normal air temperature. Normal air temperature. Are you okay? Normal air temperature. Now, if at that same point I trace it to touch the saturated, that is the vapor pressure, right? If I trace the vapor pressure to touch the saturated vapor pressure curve, the corresponding x-axis value is going to be a temperature, and that temperature is what? The dew point temperature. So when we were looking at the mathematical expression, I told you that the normal temperature in that equation will give you the saturated, and the dew point temperature in the equation will give you the unsaturated. When you come to the curve, to the same thing, right? The unsaturated air pressure, which is this E, right? When I trace it to the SVP curve, the corresponding temperature that I'll get is my what? My dew point temperature. But when I trace the normal temperature to touch the SVP curve, I'll get what? My saturated vapor pressure. So in question, when you're going to solve question, is two things. Just look at, if you are asked to find saturated, use the normal T. If you're asked to find the unsaturated, use the dew point. You get it? So if you want dew point, use the unsaturated to get your dew point, and as simple as that. I hope we all understand. So now let's take some example and see how we do about it. All right, so let's look at this example. So they said the relative humidity of air mass at temperature is 24 degrees Celsius. So relative humidity is what? 64 degrees Celsius. And the normal air mass temperature is 24 degrees Celsius. Now, using the graph below, estimate the moisture deficit, that is SD, moisture deficit or the saturated deficit, and the dew point temperature. So these are the two parameters that we are supposed to find. Now, we have one big parameter, this parameter here. I'm coming. We have this parameter here that we have this. So if I trace this on the graph, what am I going to get? I'm going to get what? The saturated vapor pressure, right? So let's find it. So we come to the temperature side. Let me change my color to blue so that we can clearly see. We are here. So we have to look for 24 degrees Celsius. Now let's see the interval. You need to read the interval. This is 5 and this is 15. So the interval, the difference is 10. And there are how many intervals? 1, 2, 3, 4, 5. 5 intervals. So divide by 5, that's 2. So every jump is 2. So if this is 5, this will be 7, this will be 9, this will be 11, this will be 13, this is 15. So 24, if I continue, here will be 17, here will be 19, here will be 21, and here will be, sorry, 17, 19, 21, 23, then 25. All right, so 24 will be in between 23 and 25, right? So the middle of 24. 24 will be somewhere here in the middle. So let's trace it. We touch the curve. Now it's not straight, but if you have a ruler and you trace it, you get a straight line, right? Now the reason why we are tracing this 24 is because you know that this curve relates the vapor pressure and temperature. So if I trace the temperature, I can get a corresponding vapor pressure. Now this temperature is air mass temperature, and I told that air mass temperature. So this one is not, pardon me, it's not straight. So we need to know what value this is. Make sure you do it your straight. So this is 20, this is 21, 20, 22, 23, 24, and 25. So let me do it so that you can clearly see what we are doing here. So this is 21, this is 22, this is 23, and this is 24. All right, let me zoom in. Let me zoom in. So this is where we got it. So the um the how do you call it, the saturated vapor pressure there is 23, right? So 23, so we have, oh pardon me, I'm trying to fix it. So we know that the E that we've gotten, that is saturated vapor pressure, is what, 23 millimeters what, mercury, right? Now from that we've gotten this. Now we need to find what saturation, that's the first part. We need to find saturation deficit. Now, what's saturation deficit? Is the saturated vapor pressure minus what? The vapor pressure. Now, do we know vapor pressure? No. But we know that the relative humidity is equal to what? Vapor pressure over the saturated vapor pressure times what? 100%, right? Now, they give us the relative humidity to be 64. We don't know vapor pressure, but we know saturated vapor pressure 23 times what? 100. So we are going to get over 1. So when we cross multiply, we are going to get 64 times 23 over 100 equal to E, right? Okay, so let's find out what we are going to get. So the vapor pressure is going to be 14.712, and the unit will be millimeters of mercury. So getting that, we can find our saturation deficit or the moisture deficit is the same thing. So 23 minus 14.712, and so the saturation deficit is going to be, our saturation deficit is going to be 8.28 millimeters of mercury. We need to bring the unit. Now the last thing is to find the dew point temperature. Now, how do we get dew point temperature from the curve? We need vapor pressure. So we need a vapor pressure of 14.73. So we count to the vapor pressure as this. This is the vapor. So 14.72. So this is 10, 11, 12, 13, and 14. So it's going to be somewhere close to 15. It's not, so let me open up that we can see it. So it's close to 15, but it's not 15. So I trace it to the curve. Oh, sorry, I'm not doing it well. So that, and I bring it down. And so that is 17. That is what, 17 degrees Celsius. And so the dew point temperature, and so the dew point temperature from the curve is what, 17 degrees Celsius. So you see how we go about it. Let's take the other example and see. So let's see this one. So the air mass of temperature. So the temperature of the air mass is 26 degrees Celsius. Close to dew point. So the dew point temperature is 11 degrees Celsius. What is the saturation deficit? That's the first one. Saturation deficit. And what? Estimate the relative humidity. Now, with these temperatures, we can find, so this temperature, we can use it to find the saturated vapor pressure. And with this temperature, we can find the vapor pressure. So we just have to do is straight. So let's come to the curve here. Let me change the color. Let me use this one. And let me open up the graph a little bit. So, um, so the temperatures that we are working with is 26. So 26. So this is 25, this is 27. So 26 will be in the middle. So the middle somewhere here. Then and trace this thing. When you are doing, make sure you use a ruler. I'm not using a ruler now, so that's why I'm working. So we have 25. So I can say that um for temperature of 26 degrees Celsius, we had a saturated vapor pressure of what? Of 25 millimeters of mercury. I'm just writing this down. Then the dew point temperature of 11. This is 7, 9, and 11. So the 11 is here. So easy to trace. Now this dew point will give us the normal air pressure, right? Normal air pressure. So that one is what? 10. So the dew point, which was 11 degrees Celsius, gave us a vapor pressure of what? 10 millimeters mercury. So now let's come to the question itself. So with this, we can find, so now I can see that my saturated vapor pressure is 25 millimeters mercury and my vapor pressure is what? 10 millimeters what? Mercury. Now my saturation deficit is going to be what? ES minus E. So my saturation deficit, ES is what? 25, E is what? 10. And so I'm going to get 15 millimeters what? Mercury. Now, what is my relative humidity? So my relative humidity is what? My vapor pressure or my saturated times what? 100%. Um, times 100%. So my relative humidity is going to be what? 10 over 25 times what? 100. This will go here 1, this will go here 4. And so my relative humidity is what? 40 degrees. I'm sorry, 40%. And so that will bring us to the end of these questions. Make sure you share, you like, and subscribe. And you comment anything that you don't understand, comment it, and we'll bring you further explanation to it. See you in another video. Bye.